It's highly likely that you've known people with cancer in your life. For example, some celebrities that you might know with cancer are Hugh Jackman, Chadwick Boseman, or even Supreme Court Justice Ruth Bader Ginsburg. My name is Andrew Pranger, and I'm a last semester biology student at Purdue University. Additionally, I'm also an intern with Moderna Therapeutics. I have award-winning research in biophysics, and I've taken research classes on CRISPR-Cas9 technology. Today, I want to talk to you about CRISPR-Cas9 technology, a gene editing method, and I want to talk to you about how it might impact all of our lives. So first, I want to talk a little bit about gene editing, which is a method of going in and altering the human genome. Essentially, genetics is what makes us us, right? I have blue hair, I have blue eyes, I have brown hair, I have a height of 5'9". These things are all determined by my genetics. But what if I had a way of going in and altering these traits of mine? That is possible by CRISPR-Cas9. You go in with essentially a little pair of scissors, you cut out the part that was defined by XYZ sequence, and you go in and you replace it. But what would happen if we didn't regulate this? So, CRISPR-Cas9 stands for Clustered Regulated Interspaced Sequence of Palindromic Repeats, which essentially means a little area of repeated genetics, or exons. So what happens is the Cas9 protein goes in, cuts that out, replaces it, and then your new genetics take place. So this has potential for editing tissues, disease treatment, even the GMOs in your food. So that's all highlighted in a paper in 2020 by Anglu in the bioethical issues of genome editing, which we're going to break into here in a second. So we need to talk about the good, right? This sounds great. We can do quick editing for quick results. That's how companies such as Moderna and Pfizer were able to quickly release their COVID-19 vaccines. Additionally, medical pathways for challenging diseases. What about cancer or Duchenne muscular dystrophy? Those would be examples of diseases that we can take on using CRISPR-Cas9 technology. Okay, so the bad. What about missing regulation? So I want to introduce you to a Chinese scientist named Dr. He. So Dr. He is highlighted in a paper by Karnowski in 2020, and the What CRISPR Baby Prison Sentences Mean for Research in Nature News talks about is he is a biophysicist who essentially announced to the world that he had edited the first human embryos. Problem, no animal embryos up to this point in 2019 had ever been edited, even including pigs, cows, chickens, you name it, let alone humans. He had done this, as described by the scientific community, mostly for the selfish purpose of his own and for the families that he did it for. So he was sentenced to jail, and he's now disgraced by the scientific community for obvious reasons. But also in 2019, China, they were taking on the early stages of the COVID pandemic. So most of this kind of went under the radar, as talked about by Mir in their 2022 paper, Regulations and Challenges for Law Enforcement to Combat Its Dual Use of CRISPR-Cas9. So why did we not get any sort of regulation to follow CRISPR-Cas9 as a result of somebody violating ethical code such as that? So it's come to me and my attention that I believe we need to create a protocol. So why not just ban CRISPR-Cas9 altogether? Well, the Center for Disease Control and Prevention highlighted that from 2001 to 2020, and this is kind of why I talked about cancer in the beginning of my presentation, that cancer deaths had dropped by 20% in the United States, which is amazing, yet they are still the second highest cause of death here in the United States. CRISPR-Cas9 is the leading potential for a cure to cancer here in the US. So, Rattan in 2017 discussed a promising genetic engineering approach to creating CRISPR exon libraries. Essentially, imagine a dictionary where you could go in, look at a disease, say, this is where, thanks to the Human Genome Project, we know where the genetic location of some disease is in our body. CRISPR knows where to go, and it essentially uses little Google Maps. It goes inside your body, cuts out the bad genes, and it replaces it with good ones. We could cure so many things if we just knew how to regulate the development of CRISPR. So we need to use the guidance of scientists to harness this power safely. So my solution, we need a legal protocol, and we need to do it now. As we've seen the problem with AI and the rampant development of technology, prior to any objection that might come, we cannot wait any longer. It was only 23 years ago that we saw Y2K and people freak out about computers not counting to 2000. Now we see deepfakes and we see ChatGPT. It's clear we can't wait. So my goal is to establish a department and a legal protocol to oversee genetic editing outside the FDA. And this is why I believe that all of us should be preaching to our government to do something about this. So the first step is support good endeavors of good faith CRISPR-Cas9 research done by scientists. Second, establish a protocol in high quality while maintaining efficiency to ensure that this gets done quickly. And third, we need to establish a committee of honorable scientists and politicians to head a department to oversee genetic engineering.